Okay, so what we have been looking at in the past few videos and chapters is the correlation. Okay, so the correlation, we know, tells us the strength associated between two variables, the response and explanatory. It doesn't tell us anything more. It just says, is it strong or weak? Okay, it doesn't tell us anything about the source or whether it's credible. Okay, so what we're going to be doing is I'm just going to start with a quick video that just demonstrates this concept.
What we call them lurking variables. Take, for example, a study that found people who owned 2 cars lived longer than people who owned only 1 car. Those who owned 3 cars were even more likely to live a longer life, and so on. Does this mean buying more cars will allow you to avoid death? No, of course not. In this case, the lurking variable is the car buyer's affluence. Richer individuals own more cars and tend to live longer, probably because they have access to better medical care and healthier food. The cars have nothing to do with it.
Okay, so what we're going to look for now is some possible non-causal explanations for an association. Okay, the first one we're looking at is a common response. Alright, if I had a question and the variables were applying sunscreen and fainting, okay, those are 2 common variables that are related directly to the temperature. On a hot day, people are more likely to put on sunscreen, and they are more likely to faint when it's hot. When we have this, we call this a third variable, and it is an exception rather than a rule. Okay, this often turns into a situation which is a lot more complex rather than what they're looking at. The second one we're going to be looking at is confounding variables. Okay, if we were looking at crime rates and unemployment in a city, okay, if we're looking at that, they are directly related. We don't know which one is the explanatory because either could be. Crime rates could trigger unemployment, or unemployment could trigger crime rates. So in this case, we have no set explanatory variable, which we can't go any further with that because we don't know the actual cause for the association. The very last thing we're going to go through is coincidence. Okay, if I was going through, if we were looking at statistics and say people that consume more butter in America have a direct relation to higher divorce rates. Okay, if that had a strong correlation between divorce rates and consuming butter, we can say, well, that isn't likely, and that is just a coincidence that people who consume more butter are more likely to be divorced. There is no actual theoretical logic behind that. It is purely a coincidence. Okay, what we're going to do now is just have a quick look at the first question from exercise 2C. Okay, so this is question 1, so we'll go through it all together. We've got a study of primary school children aged 5 to 11 years find a strong positive correlation between height and score on a math test. Does this mean that taller people are better at maths? What common cause might counter this conclusion? Okay, so what we've asked here is, does being taller relate to being better at math? Okay, first things first, we need to think of that. Do we think that is possible? Let's go through. Do we think that is just a coincidence? Is there a common response or confounding variables? Well, people being taller and being better at math, that is probably just a coincidence. There isn't anything really more to go off that. When we think of it, I would just leave it at that, and I'm just going to put this in dot points for you, okay? So I've got it here, and I've got, no, being taller doesn't relate to high mathematical scores. And then we can say, well, why is that? Okay, we need to justify our responses. Okay, so when we've got that, we've got, well, older people are generally taller, so we can look more at, well, older people are probably more likely to do better on mathematical tests, and that might be our actual association. So remember, if I was looking at older people, 10, 11, they're more likely to be taller than those that are 5 and 6. So I would say, well, age is likely to be the common cause for this association.